Okay, so today we're starting a new topic, 9.08, on fractions. Your title's at the top, adding and subtracting fractions, and your LO is in the green box in the middle of your screen. First of all, here's a moment to reflect on any homework that you have. Your teacher may want to inform you of what the homework is, or if you're working through Hegarty, using your skills that you need to develop from half term 1, then that's a good idea, or even the topics that we've recently covered. Here's an article for you that shows the links between Turing's mathematical patterns that he hypothesized back in the 50s and the way that a lot of schools and universities now are actually finding links between things like the stripes on a tiger, on zebrafish, the spots on leopards, and the spacing in rows of alligator teeth. So these things in nature have been shown to share the same kind of characteristics as these Turing patterns. There was also something on fairy circles in New Zealand that show how these grow can also be linked to Turing patterns. So it's something interesting to look at there. Local lad as well. He was born in London but studied up in Manchester. So I'm sure you'll be able to find that article if you desire. So here's your retrieval task. So can you pause the video now and complete this for the next 10 minutes? Okay, so here's your answers. Can you be sure to green pen your work and put any corrections in there and mark any ones that you got right? Okay, so here's what we'll be doing during this topic. Adding and subtracting, multiplying and dividing. We'll be dealing with what order to do these in. So we'll be re-looking at BIDMAS, looking at reciprocals and other things. So the success criteria for this lesson, we must be able to turn fractions from mixed numbers into improper fractions. We must be able to find the lowest common denominator when our denominators aren't the same. And then, once we've done that, we just add or subtract, remembering to keep an eye on the symbol before each fraction. So let's have a look at our first one. So we have 3 whole ones and 4/6, and then 2 whole ones and 5/6. So first of all, from our success criteria, what we need to do is we need to take our 3 whole ones and 4/6, and we need to turn that improper. So, whoops. So, if we have our 3 whole ones and our cakes are cut into 6 equal pieces, then our first cake would have 6 pieces, second one would have 12, and third would have 18. So we've got 18 sixths and 4/6. So together that gives us 22. With our second fraction, we have 2 whole cakes, which is 6 pieces and 12 pieces, and then we also have 5/6, so we have 17 pieces in total. Now that our denominators are the same, all we have to do is add the numerators. So 22 adds 17 gives you 39 sixths, and now we need to turn this fraction into a mixed number. So if we're cutting our cakes into 6 pieces, yeah, that means that we can get 6 whole cakes out of that, because 6 whole cakes would be 36 pieces, and then we have 3 pieces left because we have 39. So then we can divide and simplify further the top and the bottom by dividing the top and the bottom of our fraction both by 3. We have to divide by the same number on the top and the bottom so that our fraction remains equivalent. So now if you can pause the video and spend 2 minutes trying to solve the we do. Okay, so here we are. Our 3 whole ones and 7/8. The 3 whole ones would account for 8, 16, 24 pieces. Add 7 gives us 31. Our next fraction, the 2 whole ones would account for 8, 16 pieces, plus the 5 gives us 21. We then have to add our numerators together to get 52/8. The numerator stays the same. And then on the bottom, So then the next line, what we have to do is we have to turn it into a mixed number. So we know from our 8 cakes, our first cake would take 8 pieces, then 16, then 24, then 32, then 40, then 48. So we've got 6 whole cakes there with 48 pieces, and we still have 4 pieces left. So that's where this comes from, 4/8. So now we divide the top and the bottom by 2, and we get our final answer simplified. So if you can copy that down, then we'll move on to the next one. So now we're looking to subtract. So again, we do the same. Turn our fractions improper. So 3 whole cakes will be 24/8, and then 5/8 gives us 29. Remember the symbol before our fraction. So this fraction is negative 2 7/8. So the 2 whole ones will be 16/8. Add the 7/8, we get 23, and then we take away our numerators, seeing as the denominators are the same. So we end up with 6/8. Divide the top and the bottom by 2, and we get our final answer of 3/4. So if you can pause the video now and give the we do a go. Remember to keep hold of the symbol before the fraction. Okay, so here we go. So 3 3/8 becomes this. Negative 2 7 7/8 becomes this. And we just take away our numerators. So 27 take away 23 gives us 4. And we're talking about eighths here. So 4/8. Again, 4/8 is equivalent to a half, as we divide the top and the bottom by 2. Make sure you copy that down. So now, we're a little bit more complicated. We have more than one fraction now, more than 2 fractions, sorry. So let's have a look at the first one. Again, we're just turning them improper, remembering to maintain the symbol. And now we have all the denominators the same. So we do 29 take away 23, which gives us 6/8. 6/8 subtract 14/8. It's going to leave us negative. So we're going to have minus or negative 8/8, which when we divide the top and the bottom by 8, what does that leave us with? That leaves us with minus 1/1, which is just minus 1. So if you get that copied down, and then try and work through the we do. So here's the answer for the we do. First of all, we have to turn them from mixed numbers into improper fractions. So 3 whole ones we know will be 24/8. Add the 3/8, we get 27/8. Remembering to maintain our signs. And then again, we get an answer of minus 1. So if you can copy that down. Okay, so now for example 6, we're moving on to not having the same denominator. So let's give this a go. So first of all, we've turned all our fractions improper. We've got good practice doing this now, and it'll start to crop up on your retrieval tasks. So as we notice, all of our denominators now are not the same. So we need to be able to find a common denominator now. So if we notice, all of these denominators have 24 in their times tables. So first of all, this fraction here, if we times the top and the bottom, because we have to times the top and the bottom to make sure it's equivalent, by 3. 23 times 3 gives us 69. 8 times 3 gives us 24. So now what do we have to times our second fraction by? So we times the bottom by 2, and therefore that means that we have to times the top by 2. So we get 34 on the top, 24 on the bottom. Our last fraction, 25 over 24, is already has that 24 denominator that we're after. So that can stay as is. So then we just take away the numerators. So we have positive 69, take away 34, which gives us positive 35. 35 over 24, take away 25, gives us 10 over 24. And then what we're doing is we're dividing by 2 to simplify. So if you can copy that down and then spend 2 minutes trying to solve the we do. Okay, so here we are. We've turned them improper to start with. So this is the only one that we need to sort just to change. So one whole one will be 6 over 6. 6 over 6 add 5 over 6 gives us the 11 over 6. We're remembering to keep all the correct symbols so we've been given. And now we have to turn our denominators all the same. So again, we could use 24. So our first fraction, let me get a different colour pen. Let's try black. So our first fraction here, we have to times the top and the bottom by 3. Our second fraction here, we have to times it by 4. And our last fraction here, we have to times it by 6. Remembering the symbols. Remember the top and the bottom has to be times by 6. So now that we've got them all in the same denominator, we do 21, take away 44, take away 6, and that gives us minus 29 over 24. Now again, we can turn this into a mixed number, because if 24 makes a full cake, then we've got 24 over 24, which gives us the negative 1, and then we also still have 5 over 24 left. So copy that down, and then we'll move on to some examples that you do independently. Here we go, here's the first set of questions. If you can pause the video now and take 5 minutes to try and solve these additions and subtractions when the denominators are the same. Okay, and here are the answers for that first one. Make sure you're correcting your answers. Make sure you're ticking the ones that you've got correct. And now here are some examples where the denominators aren't the same. So these should be a bit trickier. Here you're going to have to find your lowest common denominators. Take 5 minutes to complete this. And here are your answers. Remember to simplify your answers and turn them back into mixed numbers. Here's another opportunity to look at that article on Alan Turing and his work in the field of structural biology. And another chance to think about the homeworks or any work you can do to improve your skills. Now the teacher can take a moment to reflect on who should get the top award and the academic points. Well done, guys. Have a good day.